Today we're going to look at partitioning when multiplying. So we've done partitioning before when we've done adding, but I'm going to show you how to do it when we're multiplying. Partitioning just means that we're breaking something up into smaller parts. Okay, so we're going to look at 7 times 6 to get us started. So we're over here, 7 times 6, and I've built an array to show you. So I've got 1, 2, 3, 4, 5, 6, 7 across the top, and 1, 2, 3, 4, 5, 6 counters across the bottom. So we have, I'll just write it in, we've got 7 across the top times 6 across the bottom, or across the side. Now, you guys might be thinking, well, Mrs. Beaton, I'll just use the commutative and I'll just write this as 6 times 7. And I could just do 3 times 7 first, and then double it to make 6 times 7, which is absolutely true. You could use those skills, but I'm just going to give you a third skill for multiplying today, and you can decide when you get a problem which one of the 3 things that you will know how to do you would like to use. Okay, so how we're going to get started is when we're thinking about now the 7 times table. I don't particularly like the 7 times table because it's not one of these nice ones that you can double, but it is one that partitions really well. So what I'm going to do is I'm just going to split this array into 2 separate arrays. So I'm just going to draw a line down through here, and then all of a sudden on this side I don't have 7 times 6 anymore. I have 2 times 6. Okay, and then over here I have 1, 2, 3, 4, 5. And then down the side I got 6 times 6. Okay, so what I've done is instead of having one great big array, I've partitioned it, or split it, into 2 separate arrays. And all I'm going to do is I'm going to solve one and then solve the other one, and then I'm just going to add them together because I haven't taken any away. None of my bits of my array have gone anywhere. I'm just looking at it now as 2 separate things. So how I would write it is I'd write 2 times 6. Okay, and we'd figure out what that equals, and we're going to figure out what 5 times 6 equals. Okay, so 2 times 6, you know, is 12. That's a nice and easy one. And 5 times 6, you know, is 30. And then all we have to do is just add these 2 bits together. So then we know that 7 times 6 is 42. All right, and how you might write it out if you were doing the whole kit and caboodle is you'd write 7 times 6 is equal to, and then in brackets, and you have to do it in brackets so that you know that they're 2 separate arrays, 2 times 6 plus this 5 times 6, okay? And then we'd maybe work, and then we'd put it out here, which would be equal to 12 plus 30, and 12 plus 30 is equal to 42, all right? So all we've done is we've split our array into 2 separate arrays, solved them independently of each other, and then added them back together. What you might notice is that we split it into a 2 times 6 and a 5 times 6, and you might have already figured this out, but if I partition 7, I can partition 7 into a 2 and a 5, okay? And because 2 plus 5 equals 7, this all works out. Now, what's different from adding is that both of these numbers both have to multiply by 6. So don't just add the 2 and the 5 together and then multiply them again. You won't have gotten anywhere. You partition it, but you need to add the 2 separate bits together after, okay? Sometimes drawing the array is actually really quite handy. All right, we're going to move over to the other side here. We've got 9 times 5 here. And maybe you already know the answer to this question, but we're just showing you how to use partitioning when multiplying. It's really, really handy when we have tens and units, but we'll just do it this way today. So I'm thinking 9 times 5, and I'm thinking, do you know what? I would really like to split this 9 into 2 things that I can manage. How about a 4 and a 5 instead? So instead of having one great big long array up the top, I'm going to split it here so that on this side I have 4 times 5, and on this side I have 5 times 5, and if I figure out what each of them is and then add them together, I'm in business. Okay, so we're going to do 4 times 5 equals, so this side is equal to 20, and this side, 5 times 5, is equal to 25. Now, if I add them together, I'm adding together the 20 and the 25, and I'm going to end up with 45. Okay, so if I were to write it out like I did on the other side, I would have 9 times 5 equals, and what I did was I had 9 times 5 equals 4 times 5 plus 5 times 5. And the reason that we put the brackets on is to show us that we need to solve what's in the brackets before we add them together. Okay, it's called the order of operations, and we'll look at that another time, but just for now, just know that the reason you put the brackets is to show that you've got 2 separate arrays or 2 separate questions, and you're going to solve them independently and then add them together after. So we've got 4 times 5 equals 20, plus 5 times 5 equals 25. It's not going to go down for me, so. And then that all together is equal to 45. All right, so what I'm going to do today is I'm going to give you a few questions, and I'd like you to try them out to see if you can partition the numbers into more manageable arrays. Now, I know that we just did doubling and commutative, so I know you know how to do those ones, so try not to be tempted to use doubling or commutative. I'd like you to show me that you know how, that you're trying to use partitioning, so that we can have a wee practice of it today. Okay? But yeah, if you have any questions, let me know. Enjoy!